All right, we'll start now. So today we'll start the second unit, which is symmetry in quantum mechanics 2. So till now, we have discussed about symmetry operations like space translation, time translation, and rotation. So we have discussed about three symmetry operations, namely, uh, just a second, namely space translation, then time. And we saw that if a system remains invariant, if a system remains invariant under these symmetry operations, these three symmetry operations, then something is conserved, some quantity, some physical quantity is conserved. So symmetry leads to conservation principle. That is what you also have studied in classical physics. Classical physics रे भी तमे सेही कथा already पढ़िबणी. Uh, Instead of commutator bracket, there is something called Poisson's bracket. Poisson's bracket पढ़ा हेलाଣି तो?
ଆଜ୍ଞା
Yeah. So that is kind of similar, and classical physics also tells you that symmetry leads to conservation. So conservation of momentum, linear momentum from space translation, conservation of angular momentum from rotation, and conservation of energy from time translation is very much evident from these symmetry operations. ତା ମାନେ କ'ଣ ଯେ जो force गुड़ा ଆମେ mostly we encounter like gravitational force, weak force, strong force, these forces, classical forces, are invariant under space-time translation. Whether you have space translation or time translation or rotation, these forces remains invariant, and which leads to the conservation principle of conservation of momentum, conservation of energy, conservation of angular momentum. ତମେମାନେ ସବୁବେଳେ ଶୁଣି ଆସିଥିବ ଯେ energy is conserved, that is why this thing happens. Momentum is conserved, that is why this thing happened. So ସେଇ ଯୋଉ conservation energy କାହିଁକି conserve ହବ, momentum କାହିଁକି conserve ହବ, angular momentum କାହିଁକି conserve ହବ, ତାର basic fundamental ଟା ରହୁଛି କୋଉଠି ନା symmetry. If a system remains invariant under this symmetry operations, then physical quantities will remain conserved. Okay. But in quantum mechanics, it says, however, in quantum mechanics, we also look at consequence of discrete symmetry operations, not continuous, but discrete symmetry operations. Okay. So there is one such symmetry operation is basically called your parity. It's called parity. Hmm. So which we will be. So what we expect from this unit is understand parity transformation in quantum mechanics. Understand parity transformation in quantum mechanics, and we will be able to explain the effect of parity operator on the state cat and establish its properties. What is the parity operator? What are its properties of physical significance? Then derive the transformation properties of different operators under parity and conservation. Conservation of parity conservation rule. Parity should be conserved. Understand the time reversal in classical and quantum mechanics. time reversal. That will be very much interesting. This thing will be very much interesting. And then you will be able to derive the transformation properties of wave function and different operators under time reversal and time reversal symmetry. So mostly we'll be focusing on parity and time reversal. All right. Now let us try to understand what is parity. What do we mean by parity? Okay. Let me come to my notes. So we'll be talking about parity. So parity is an operator when applied to a coordinate system transforms a right-handed system of coordinates to a left-handed system of coordinates. What does it mean? So it an operator which transforms a left-handed, right-handed coordinate system, a right-handed coordinate system to a left-handed coordinate system. All right. What does it mean? ତାମାନେ ଯଦି ଆମେ x, y, z ରେ ଅଛୁ, ଯଦି parity operator operate କଲା, parity operator or transformation or transformation, that will go to minus x, minus y, minus z. All right. ଆକୁ ଯଦି physically ଆମେ ଗୋଟେ coordinate system ରେ visualize କରିବା ପାଇଁ ଚେଷ୍ଟା କରିବା. Suppose you have your x axis, y axis, and z axis. So if you have a point P over here, huh, so what will happen? This coordinate of this point will be x, y, and z. This is your origin. Now, what does parity does? Parity parity shifts this point in the opposite direction over here, P prime, which will be basically minus x, minus y, minus z. That means it will be transforming to a diagonally opposite octet. Okay. First octet ro se diagonally opposite octet ko padayo. So we now look at the action of a special unitary operator, the parity operator. Okay. कौन सेटा? Now the parity operator is written as phi cap. Phi cap. And if we have the state vector psi and we apply phi cap, it will move it to psi prime. And this psi prime is a space inverted state. ओके तामाने कोन यार जदि x y z रे थिबो यार माइनस x माइनस y माइनस z alright. Now what happens to the expectation value? What happens to the expectation value? That is also very much important. Under parity transformation. Okay. Expectation value of any operator under parity transformation. कौन हबो ताले माने हमर जदि गुटे वेव फंक्शन साइ अछि parity ऑपरेट कले सेटा कोड को शिफ्ट हेइबो साइ प्राइम ताले parity ऑपरेटेड स्टेट रे एक्सपेक्टेशन जदि हमें गोटे बाहर करबे ताले कोन करबे साइ प्राइम like this, right? And the interesting part is that this will be negative. This will be negative of. This will be negative of. This is important. This will be negative of psi x psi. So it is the parity କରୁଛି parity कौन କରୁଛି x टाको minus x को नहीं जाଉଛି. So similarly we can write psi prime y psi prime would be equal to minus psi y psi. Right? And psi prime z psi prime will be equal to minus psi z psi. Yes. Why is it like that? Is that it is evident? Let's see another mathematical relation. That psi prime x psi, what will be? Psi prime x psi prime will be equal to what? Pi operating on psi, right? So that will be pi psi dag or yes, pi psi dag x pi psi like this. The pi psi dag would be equal to psi dag or let me write it this way. It will be psi cat and pi dag x pi psi. Now this will be equal to what? This should be equal to minus psi x psi. This implies pi dagger x phi would be equal to minus x. So if that is the case, what we can write? Pi dagger x phi would be equal to how much?
minus pi x.
Minus pi x. Minus pi x. Right? But is pi unitary? is pi unitary? Yes, that's what we have told in the beginning, right? Pi has to be an unitary operator. So pi is a unitary operator. So that's why pi dagger pi will be equal to identity. Isn't it? This implies this part goes to identity. So x pi plus pi x is equal to 0. Right? Now, do you remember ଆକୁ କଣ ଲେଖୁଥିଲ quantum mechanics 1 ରେ ମନେ ପଡୁଛି? Do you remember that? ମାଇନସ୍ ଥିଲେ କଣ ଲେଖାଯାଏ? ମାଇନସ୍ ଥିଲେ କମ୍ୟୁଟେଟର ବ୍ରାକେଟ। ଏଇ ପ୍ଲସ୍ ଟା ଯଦି ଏଠି ମାଇନସ୍ ହେଇଥାନ୍ତା ତାହେଲେ ମୁଁ ଲେଖିଥାନ୍ତି x ବାଇ କମ୍ୟୁଟେଟର। ଯେହେତୁ ପ୍ଲସ୍ ଅଛି ତାକୁ କଣ ଲେଖିବି?
curly bracket.
कर्ली ब्रैकेट एंटी कम्यूटेटर ब्रैकेट एंटी कम्यूटेटर है एंटी कम्यूटेटर
Yes, sir.
माइनस टा नहीं प्लस अच्छी so the anti commutator bracket is equal to 0 so similarly we can show y cap pi is equal to 0 and z cap pi is equal to 0 all right so position operator anti commute with parity operator position operator anti commute with parity operator all right and another thing we can also write pi operating on a state x will basically take it to minus x state minus x right এই কথাটা আমাকে মনে রাখবার আছে প্যারিটি অপারেটর কোন করে তাকে নেগেটিভ আর্গুমেন্ট স্টেট কু নিয়ে যায় এক্স ওয়াই জেড কু মাইনাস এক্স মাইনাস ওয়াই মাইনাস জেড কু নিয়ে যায় ঠিক আছে now any arbitrary so এই যে মাইনাস এক্স কু নিয়ে যাଉଛି তাকে কোন করি হবে ଆଉ ଗୋଟେ ହଉଛି ଯେ ତାକୁ ଦି ଥର ଅପରେଟ କଲେ ସେଟା ଆଇଡେଣ୍ଟିଟି ହବ ଏଇଟା ଏଇ କଥାଟା ବି ମନେ ରଖିବ ମାନେ ଗୋଟେ ଯଦି ଏକ୍ସ ୱାଇ ଜେଡ୍ ଟା ट्रांसफॉर्म होची माइनस एक्स माइनस वाई माइनस जेड को अंडर पैरिटी आउ थरे जदि पैरिटी ऑपरेट करिवि तले से कोन हिजो एक्स वाई जेड तो माने दिन समान हे गेला आइडेंटिटी सो दैट मींस पाई इनटू पाई would be equal to identity or pi square would be equal to identity ये कथाटाই মতে মনে রাখবে ঠিক আছে let us come to your area. Yeah, this is what we talked about, and this is what we also. And pi dagger will be equal to. We can also show. So the action of two successive applications of parity operator on a state gate brings it back to the original. We can also show that the parity operator is also Hermitian. Pi dagger is equal to pi. Pi dagger is equal to pi. Now what happens to this transformation operators? What happens to these transformation operators? এই তো গুলো প্যারিটিটা কোন আমি জানবো প্যারিটি অপারেটরটা কোন সে বিষয়ে আমি জানবো কিন্তু প্যারিটি অপারেটস প্যারিটি হবা দ্বারা অপারেটর গুলা কেমতি চেঞ্জ হউଛନ୍ତି that's what it is telling in the classical picture p is equal to m dr by dt right mv Momentum is equal to mass times velocity.
Yes, sir.
Uh, Velocity is dr by dt. So it would be reasonable to expect that under a parity transformation, momentum should transform in the same way as x. X যদি minus x କୁ ଯାଉଥିଲା ତାହେଲେ p ଟା minus p କି କାରଣ mass ତ change ହେବାର ନାହିଁ. Mass is not changing. Sign. ତେଣୁ ଏଇ dr by dt ରେ r ଟା minus r କୁ ପଳେଇବ. ତାହେଲେ p ଟା minus p କୁ ଯିବ. That is why we expect, right? Now to look at the action of parity operator and momentum operator, let us take the definition of momentum operator as a generator of translation. ଏଇଟା ଯୋଉଟା ଆମେ ଆଗରୁ କରିଥିଲେ. ଯଦି translation କଲେ କେମିତି ହେଇଥିଲା? Identity minus I epsilon x px by h cross. Right? Now what will happen if we try to find what happens to this operator translation under parity? Under parity କଣ ହବ? ସେଇ କଥାଟା ଏଇଟା ଟିକେ ବୁଝିବା। ସେ କହୁଛି let us consider an infinitesimal translation epsilon x of a system located at p is equal to x0. ଗୋଟେ system ଟା x0 ରେ ଥିଲା ତାକୁ ଆମେ କେତେ translate କଲୁ epsilon x which moves to the point p1 which is x0 plus epsilon x. x0 plus ମାନେ p ରେ ଥିଲା ଏଇଠି ଥିଲା ସେ p1 କୁ ଆସିଲା which is x0 plus epsilon x followed by a space inversion which then locates the system to p prime. p1 ରେ ଥିଲା ସେ ତାପରେ କଣ ହେଲା ସ୍ପେସ୍ ଇନଭର୍ସନ ହେଲା ମାନେ x ଯୋଉ ପଏଣ୍ଟ ରେ ଥିଲା ତାର ନେଗେଟିଭ ପଏଣ୍ଟ କୁ ପଳେଇବ ସେମାନେ କୋଉଠକୁ ଯିବ ଏଇଠୁ ଏଠିକି ଆସିଲା ସ୍ପେସ୍ ଇନଭର୍ସନ ହେଲା minus of x0 plus epsilon x. Next consider the following sequence of operation. कौन operation हमें follow करिवे? A space inversion at x p is equal to x0 which should locate the system to minus x0. प्रथम x0 ରୁ minus x0 तापर ट्रांसलेट केते करिवे लेफ्ट को जिवे एठी हम ट्रांसलेट को पड़े करथिले प्लस एप्सिलॉन x एठी हम ट्रांसलेशन केते करिवे माइनस एप्सिलॉन x पछ को जिवे त माने प्रथमे ट्रांसलेशन करिकी सॉरी प्रथमे हां प्रथमे ट्रांसलेशन करिकी तापर पाई करिबा आउ प्रथमे पाई करिकी तापर ट्रांसलेशन कले हमको माइनस एप्सिलॉन x ट्रांसलेट करिया पई पड़ो ए कथाटा बुझी परछ ना आथरे कहूछ फास्ट कोन हमें ट्रांसलेशन फास्ट हमें कहूछ ट्रांसलेशन तापर करिबा पाई राइट रू लेफ्ट हैंड को जिबे राइट रू लेफ्ट हैंड को जिबे फास्ट ट्रांसलेशन माने p रू p प्राइम x0 रू x0 प्लस एप्सिलॉन x तापर हमें कले पाई पाई माने स्पेस इनवर्सन ताले टोटल टा माइनस हे जिवो सो इट विल गो टू माइनस x नॉट प्लस एप्सिलॉन x सेकंड टाइम में कोन करछे आगो कर दोछे स्पेस इनवर्सन आगो पाई कर दोछे आगो पाई तापर t राइट रू लेफ्ट हैंड को जिवो ठीक अछि आगो पाई कले कोन हला x नॉट x0 टा पळे आसला कोठी माइनस x0 को वर्तमान सेम पॉइंट को हमें फास्ट केस रे जो पॉइंट रे थिले सेम पॉइंट को जिबा पई हेले हमको एठी कोन करे पई पड़िबो हमें जदी एप्सिलॉन x मूव करबे तले राइट को पळे आसबे व्हिच इज रॉन्ग हमको पूरी लेफ्ट को जिबार अछि सो दैट विल बी माइनस ऑफ एप्सिलॉन x दैट इज व्हाई you have this relation कोन t epsilon x pi will be equal to pi t of minus of epsilon x. Now if you substitute मैं already t ର value ଜାଣିଛୁ ଏଠୁ t ଟା କଣ ଆମେ already ଜାଣିଛୁ so if you substitute that so what will it be I minus epsilon x px x plus pi then pi ଏଠି କଣ ହବ epsilon x ଜାଗାରେ minus epsilon x. So that is why you have a plus sign over here. ତ ତମେ bracket open କରିଦେଲେ I into pi will be pi and then px pi. ଏଠି ବି ଗୋଟେ pi ଆସିଲା, so pi pi will basically cancel. I epsilon x by x cross, I epsilon x by x cross will also cancel. What will remain is px pi plus pi px is equal to 0. Px pi plus pi px is equal to 0 or px pi anti-commutator is equal to 0. So that means momentum operator also anti-commute with the parity operator. Momentum operator also anti-commute with the parity operator. एरिया बुझिएला? Any doubt?
No, sir.
Okay. I'll take a couple of minutes, take some water, and then I'll start it. Okay, we'll start again. So anti-commutator px pi anti-commutator is equal to 0. This implies px pi plus pi px is equal to 0. So this implies if I multiply pi dagger onto the left, px pi plus pi dagger pi px will be equal to 0. Multiplying pi dagger onto the left. 0 into pi dagger. Now this becomes identity because Hermitian, right? Pi is Hermitian. So that's why pi dagger pi. Okay. Now
ମୁଁ ଶୁଭସ୍ମିତା ସାର୍ ଯୋଉ
ହଁ
ଫ୍ରଣ୍ଟରେ ଲେଖିଥିଲେ ମାନେ ଫାଷ୍ଟ କ୍ଲାସ୍ ଷ୍ଟାର୍ଟିଂରେ ଫାଷ୍ଟ ଚାପ୍ଟରରେ 3ଟା ଟପିକ୍ ଉପରେ ଲେଖିଥିଲେ କ'ଣ ସାର୍ ସେ ସବୁ ଇମ୍ପୋର୍ଟାଣ୍ଟ କହିଥିଲେ କି?
ନା ନାଇଁ ସେଟା ଇମ୍ପୋର୍ଟାଣ୍ଟ ନୁହେଁ ମାନେ ଏଇ ଚାପ୍ଟରରେ କଣ ଅଛି ମାନେ ମୁଁ କଣ ପଢିବେ ସେଇଟା କହୁଥିଲି।
ଆଚ୍ଛା ଥ୍ୟାଙ୍କ ୟୁ।